Have you ever wondered how the journey towards exploring Mars began? The quest to conquer the enigmatic red planet has been a cosmic marathon spanning over 6 decades. However, it all started in the tumultuous era of the 1960s, a time of space races and Cold War rivalry, with the Soviet Union and the United States leading the charge. The Soviets were the first off the block, launching Marsnik 1 in 1960. This was humanity's first attempt to reach out to our red neighbor. Unfortunately, Marsnik 1 never made it to its destination, failing to reach Martian orbit. Yet this initial setback did not deter the Soviet Union or other nations from pursuing the Martian dream. Just a few years later, in 1964, the United States Mariner 4 etched its name in the annals of space exploration. Mariner 4 was the first successful mission to pass through Mars' orbit. Its flyby of the red planet captured the world's imagination, revealing a cratered surface and a thin carbon dioxide atmosphere. These images were our first tangible glimpse into the Martian world. That same year, the Soviet Union launched Zond 2, which came tantalizingly close to Mars. Yet, in a twist of fate, it lost communication before it could transmit any data back to Earth. Despite these early challenges, these pioneering steps were crucial. They laid the groundwork for future missions, teaching us valuable lessons about the risks and rewards of space exploration. These initial endeavors, as daring and uncertain as they were, set the stage for more ambitious missions that would further deepen our understanding of the red planet. They sparked a fire of curiosity and determination that continues to fuel our journey to Mars. The early attempts at Mars exploration were not just about reaching a distant planet, they were about pushing the boundaries of what was scientifically and technologically possible. This spirit of exploration, of reaching out into the unknown, has defined our journey to Mars from its very inception. Now, imagine the excitement when, in the 1970s, NASA launched the Viking program. The space race was in full swing, and the Viking program was NASA's ambitious attempt to land and operate long-term missions on the enigmatic Martian surface. The program comprised 2 identical spacecraft, Viking 1 and Viking 2, each with an orbiter and a lander. The twin Voyagers were designed to capture images, analyze the Martian atmosphere, and study the surface in detail. Viking 1 was the first to arrive in June 1976. The mission was a resounding success, capturing breathtaking images of the Martian landscape. The lander analyzed the atmosphere and the surface, providing us with unprecedented data. One of the most stunning achievements was the photos Viking 1 sent back of Mars's moon, Phobos. These images gave us our first close-up look at this tiny moon, a sight that had been, until then, reserved for the Martian sky alone. Just a few months later, in August 1976, Viking 2 made its own Martian landing. It continued the exploration started by its twin, delving deeper into the mysteries of Mars. The data it provided on Martian geology and climate was invaluable, helping us understand more about the planet's past and present. These missions, though separated by millions of miles from Earth, felt incredibly close to home as the images and data they sent back transformed our understanding of Mars. They revealed a world of stark beauty, with towering volcanoes, vast canyons, and a sky tinged with pink. But they also showed a world that was seemingly barren and lifeless, far from the warm and wet planet we had hoped to find. Yet the Viking missions did more than just capture images and collect data. They fueled our curiosity, our sense of wonder, and our determination to explore the cosmos. They paved the way for future Mars missions, setting the stage for rovers like Spirit, Opportunity, and Curiosity. The Viking missions marked a significant leap in our exploration of Mars, opening up new frontiers for future explorations. They reminded us that space is vast, but not unreachable, and that our understanding of the universe is always expanding, just like the universe itself. Fast forward to the late 1990s and early 2000s, a new era of Mars exploration had dawned. The baton was now passed to the rovers and landers, the robotic explorers designed to traverse the Martian terrain and delve deeper into its secrets. In the summer of 1997, NASA introduced us to Sojourner, the first successful Mars rover. Barely the size of a microwave oven, this little rover that could spend 83 Martian days, or sols, exploring the vast rocky expanse of Ares Vallis. Sojourner's scientific exploits involved analyzing Martian rocks and soil, offering us our first close-up look at the red planet's geology. Fast forward 7 years, we met Spirit and Opportunity, the twin rovers that turned a 3-month mission into a multi-year Martian Odyssey. Spirit roamed the red planet for over 6 years, while Opportunity outdid its twin, exploring Mars for an incredible 14 years. Their tireless exploration and detailed geological analysis revealed signs of past water on Mars, a discovery that fundamentally reshaped our understanding of the planet. Spirit and Opportunity found evidence that Mars once had wet conditions that could have harbored microbial life. Their findings painted a picture of a planet that, billions of years ago, was considerably wetter and warmer, with a thicker atmosphere, potentially capable of supporting life as we know it. However, the quest for Martian secrets didn't end there. In 2012, NASA's car-sized rover, Curiosity, landed in Gale Crater. Armed with the most advanced scientific instruments yet sent to Mars, Curiosity set out to explore the crater's central mountain, Mount Sharp. Curiosity's mission was to investigate whether Mars could have once hosted life. Its most significant discovery came within the first year when it found that Gale Crater had once held a freshwater lake. This ancient lake existed around 3.5 billion years ago and could have supported microbial life. As Curiosity continues to climb Mount Sharp, it's uncovering the layered history of Mars, layer by layer. It's finding more evidence of Mars' wet past, and even clues that the planet might have been habitable for longer than we previously thought. And so, our understanding of Mars continues to evolve, one rover track at a time. From Sojourner's first steps to Curiosity's ongoing journey, each mission has brought us closer to deciphering the red planet's past and its potential to host life. These robotic explorers, each a marvel of human ingenuity and perseverance, have transformed Mars from a distant, alien world into a place we can imagine exploring ourselves, perhaps even living on one day. They've opened the door to a future where humans and robots could work together to uncover the mysteries of the universe. The rovers and landers of the modern age have brought us closer than ever to answering the question, was there ever life on Mars? As we stand on the precipice of a new era of Mars exploration, we can only wonder what revelations the future holds. But one thing is for certain, our journey to Mars is just beginning. As we stand at the threshold of a new era, what does the future hold for Mars exploration? This question sparks a sense of wonder and curiosity in our minds as we prepare to embark on the next chapter of our cosmic odyssey. The future of Mars exploration is teeming with exciting missions. NASA's Perseverance rover, which touched down on Mars in February 2021, is one such mission. As the most advanced robotic explorer ever sent to the red planet, Perseverance is tasked with an ambitious goal. It's not just there to take pretty pictures. Its mission is to search for signs of past microbial life, studying the Martian climate and geology, and collecting samples that might one day be returned to Earth. Imagine, for a moment, the significance of this quest. If Perseverance succeeds in its mission, we may be on the precipice of one of the most profound discoveries in human history, the confirmation of life beyond our home planet. But the story doesn't end there. The upcoming sample return mission is another ambitious endeavor. This mission aims to bring back the samples collected by Perseverance to Earth. The importance of this mission cannot be overstated. Studying these samples in our laboratories could provide us with unparalleled insights into the Martian environment and potentially its past life. These missions represent the epitome of human curiosity and our relentless pursuit of knowledge. They embody our desire to reach further into the cosmos, to understand our place within it, and to answer the age-old question, are we alone in the universe? There's no denying that the road to Mars is challenging, filled with unknowns and risks. But with each mission, we inch closer to unraveling the mysteries of the red planet. Our journey is driven by the collective curiosity of humanity, fueled by our technological advancements, and inspired by the boundless possibilities of what we might discover. As our fascination with the red planet continues to grow, so does our determination to unravel its secrets. Who knows what mysteries Mars holds for us to discover? From the pioneering steps of the 1960s to the anticipated missions of the future, our journey to Mars has been a historical odyssey. We've embarked on a cosmic voyage through time, tracing the significant milestones in our exploration of the enigmatic red planet. Early endeavors by the Soviet Union and the United States marked the beginning of our Martian saga. Then came the Viking Era in the 1970s, with twin Voyagers providing valuable data on Martian geology and climate. The modern age saw the deployment of rovers and landers, with each mission unearthing new insights about Mars. The future beckons with exciting missions like Perseverance and the upcoming sample return mission, promising to unravel more Martian mysteries. Each step, Each discovery feeds our fascination and fuels our quest to understand the secrets of Mars. As we continue to explore Mars, each mission brings us one step closer to answering the ultimate question: are we alone in the universe?